Or, or otherwise, if you can help me to find Peggy, or whatever is easier. In the interest of time. Good to go? Thank you. All right. Hello, okay. Can everybody hear me? Good. There you go. Hi, Sai. Hello and welcome to the Joint Spinach Start Week 2024 conference. This is session 7, Biodiversity Data, Software and Workflows, Beyond Observations, Beyond Biodiversity. And I am your moderator, Javier Molina. My co-moderator is Peggy Newman. Our symposium co-organizers is Francisco Pandos, sitting on the back, and Sophie Archambault. And I don't know whether Vicente Ruiz is joining us online. This year's meeting was possible in part by the generosity of our sponsors. We are grateful to them and Oki Congress for today's tech support. These sessions will be recorded for later viewing by registrants and eventually posted in the Spinach and Tarwig YouTube channels for public viewing. Please speak slowly and clearly to the benefit of all attendees. Thank you all for joining us, and thank you to all the speakers in these sessions. Each presenter will talk for 10 minutes. There will be 3 minutes for questions, and then there will be 2 minutes for changeover. There will be time at the end of the presentations for discussion. So if you have any questions further questions for the presenters or for the organizers, please get them ready. If you are attending online, please ask the questions to the speakers using the chat feature in Zoom. Peggy will ask them to the presenters for you. If you are attending the session here in person, just approach the microphone, please, before you ask your questions, and also consider whether introducing yourself. If you'd like to continue the conversation online after the session, continue using the chat function in Oxford Abstracts. A group chat has been created for this session. And, we are almost there. By participating in this conference, you agree to abide by the Spinach Start Week 2024 Code of Conduct. If you have technical difficulties, please, we appreciate your patience. So without further ado, let me check first whether Fernando is online for our first session. Fernando, are you there? I think, it was a possibility he couldn't join us. So in the interest to keep to the schedule, let's wait for another 10 minutes or so. Let's start or resume at 15 minutes past the hour so we can go with the second presentation. Thank you. Just double checking for people that join only a few minutes later, either here on face-to-face or online. The first presenter is not around, so we are going to resume at 15 minutes past the hour, so at least roughly 5 minutes. No, I have to mark it.
I don't think they follow it.
Yeah. That is for the live session. Later on, everybody on the chat.
I don't know, I don't know everything. So I'm trying to get the. Yeah. So we're part of the initial migration. So Uber will come on by.
Yeah, I was trying to speak
And
to
it's really
the schedule.
I say probably because we're actually attempting to and haven't felt until okay, so I put you in one of the points. Yes, so he said, like, you're actually put you in here, and actually, you're also, they wanted to reach out to me about, so hopefully we work on making that just
All right, everybody. Thanks for the wait. I think we are now ready to resume and keep according to our schedule. So our next presenter is Clara Baringo, joining us from Brazil. We will be playing her recording. However, Clara is online to answer any questions after this. All right. If you can help us with Clara's presentation. You didn't receive? Oh, okay. Yeah. Clara, can you hear us? Looks like we don't have your video here. Are you able to present online?
I upload the video in the open folder thing. You don't have it?
No, I think it's going to be very late. Are you able to share your screen and just take us through your presentation?
Yeah.
Thank you.
Oops. Just wait a minute. Okay, it's everybody.
Thank you. Over to you.
Good morning, everyone, and good evening to us. It's a pleasure to see you all again, and I appreciate the opportunity to participate remotely in the symposium. I would have loved to be there in person, but unfortunately was not possible. So in my presentation today, I will discuss ecological data and its visualization in the Living Atlas and GBIF, highlighting how it is currently done, as well as challenges and opportunities for long-term visualization. So currently at CBR, we publish sampling event data as data providers. In the Living Atlas, through the platform's interface, user can access a page with all the data providers. And one of these providers is the Long-Term Ecological Research Program, PEOG, a government program with sites and sampling areas spread across Brazil. So each site has its own research objectives, and therefore we provide a dedicated page for each one of them. So by clicking on a site, we can view the associated data sets and the number of occurrences. Currently, since it's not possible to index sampling events, the Living Atlas only indexes the occurrence data. So if users want to download additional associated measurements, they need to access the IPT and download the Darwin Core archive. This ecological program registered their data sets also in GBIF, and recently we created a network on GBIF to share data from the different data sets and institutions that are part of the program. On GBIF platform, once it's indexed, we can apply various filters, searching by event, by sampling protocol, and extension type, among others. So furthermore, by clicking on a record in a sampling event, it's possible to view at the record level all the information. Although it's possible to filter some information and measurements in GBIF, visualizing ecological data and in the Living Atlas and at GBIF remains a challenge. So currently, Living Atlas Brazil maintains a partnership with the Renova Foundation. This foundation is responsible for the mobilization of efforts to repair the damages caused by the collapse of the Samarco Dam in 2015. The foundation brings together technicians and specialists from various fields of knowledge, along with dozens of environmental entities and Brazilian scientific expertise to conduct research. All this data will be published through national platforms to facilitate further research. So currently they're monitoring and data collection programs with various sampling protocols and measurements, as well as manual and automatic collection stations that gather real-time information. All the information from a specific program of the foundation is organized on this site, just one program of the whole projects and programs. It displays the sampling stations, all here, divided by environments such as river, lagoons, and coastal zones and estuarios. So water quality measurements are collected, including variables like mercury, alkalinity, salinity, and other compounds, and mining residues without associated occurrence. So by selecting the download option here, you can download data. The system allows for filtering data downloads by station, sample type, parameter or variable within with a specified period of time that cannot exceed 1 year. And additionally, taxonomic lists of aquatic communities can be downloaded as separate data. The system also creates informational dashboards for managers to monitor some indices estimated from the calculated data. This site is not standardized and data upload is nearly manual. So the Foundation has requested support to properly organize the data, standardize it in Darwin Core, and improve its quality. In this way, we are publishing all data on the IPT and in Darwin Core format, standardizing all information and measurements according to a Darwin Core standards and extensions. Darwin Core Brazil, a GitHub platform we created to discuss the content of certain terms such as sampling protocol and measurement station to facilitate later visualization and development of associated graphs and dashboards. So as part of the partnership, the data flow from the Foundation will be as follows. All projects will be first registered in BioCollect, a module recently implemented in the Living Atlas Brazil. So we are developing a tool to standardize measurements and variables in the measurement facts or extension and integrate it with the IPT automatically. However, our challenge will be how to index these extensions. In Living Atlas Brazil, it will be possible to view some data currently available only as occurrence, as data in a spatial portal, and some data will be consumed directly from the IPT for BI production, dashboards, and other analysis. So as we can see here, the projects are already being stored in BioCollect and are associated with the project areas of coverage, which in this case is the Doce River Basin. The whole problem was here in this part. However, extensions are not indexed along geoccurrences. Upon reviewing the options, we found the sample datasets module, which is currently in the testing phase. This module is an excellent way to visualize extensions and protocols, variables and measurements, and it's of our great interest to implement or support its development. Ecological data in Brazil continues to grow, and this is essential to consider an appropriate visualization to meet the needs of all ecologists and researchers in the country. So we are really interested on or support its development or continue further discussing this module. So that's it. That's conclude my presentation, and thank you very much for your attention. Please find our contact information and we are available for any questions or comments. Thank you.
Thanks, Clara. Now, let's see whether there are any questions here in the room for Clara. Please don't be shy. Anything online, Peggy? Any questions? No? Very good. All right. If nothing else, then let's continue moving on. And now can I ask Dimitri Brosens to come here to stage to run his presentation? Thanks, Dimitri.
Just click. Good morning. I'm Dimitri from Belgium. Last year, I gave a small presentation about our efforts in Living Atlases. We have started the project of building a Living Atlas of Flanders just before we had to send in the abstract for this year. So no news on that this year, but maybe next year. But in the meantime, I thought this would be a very interesting story to tell about the Great Tax and List Laundry Machine. It's something that we are creating in the Research Institute for Nature and Forest and might be useful for others too, because in our institute we have a very big number of biodiversity-related applications running, and they all use different taxonomic lists. That is kind of messy in the end, and we're trying to solve this. We have the applications on common breeding birds monitoring, on flora things, flora bank, wintering waterfall, INBOVE vegetation service, etc. So most of these applications are underpinned by a great number of simple and relational databases, and that number only has been growing over the years. One thing, when I submitted the abstract, they asked us, did we use AI? Now, I did not for the abstract, but I tried to use as much AI as I can for this presentation. So the images you will see are generated by DALL-E. So I did not been drawing these things. So a lot of databases. And what is the situation in the Research Institute? All these lists are copies from each other. They are bad copies from each other. They have sometimes the same origin, but a divergent evolution. Sometimes they have completely different origin, and it's sometimes with author names, sometimes without author names. We have different ways of spelling, like with capitals, no capitals. The accents are sometimes different. They use in a very various way. What you see there, Dredgis, Sidonia, the one highlighted that are different databases. And then sometimes there's also the name of the taxon list. Also in vernacular names, Große Heidelibelle, that's German, we use German names, but sometimes it's spelled like Große Heidelibelle. So we wanted to solve these issues. We have with and without orders, like I said before. Also spellings, errors in spellings, double L, one L. We have synonyms, homonyms, what do you want? And we have also a lot of different ways of spelling the authors. So Wilson or Wills, which is probably or most probably the same person. Already 10 years ago, we tried to solve this issue by trying to centralize all these taxon lists. And we went to the NBN in the UK, and we obtained a copy of their database, of their data model. We try to implement, and they have a name server, and it's very complex. So we had our own implementation. Of course, we are not using the UK list, but we needed to have the Flemish list. Started our own name server, used it together with Recorder. People knowing the UK or the NBN would know this tool. It's still used in the Institute. We try to integrate this in data not warehouses, warehouses and databases. Also, we looked at our name server already at the time when we published our data to GBIF. So that was all standardized and used the same names for publication. Also added taxon version keys in other systems. But the thing is, it was very hard to maintain and we could not keep up. There was one person in the Institute responsible for these names, and he had to, once a scientist had a new species for Belgium, we needed to first get that species into the name server before it could be used for analysis. So that was very hard work, and we could not really cope with this. An idea was, okay, we make a simplified NBN data model. It was a database primarily to support InboVig, which is something which it's very similar as TurboVig, but our own version, of course. That's how we do it in Flanders, making our own versions. We had this Flora taxon list, used it for Futon, which is the database, taxon for Bobo, something about forests, trees, and soil biodiversity, and InboVig. And we used Snapshot to do this. But this was all very, very messy. So if we wanted to have this central taxon list, we have to heavy refactor all the tools and make sure that they could use this centralized taxon list. Also, we needed the experts to be able to change and update these taxon lists, so we did not have one person doing it for all. And also we had a lot of other info in all these different applications, like traits for Flora, measurements of facts for VIS, fish indexation system, monitoring database for fish. Schelde monitor, a Schelde is a river which we monitor, and there is also a lot of information on the groups, or if the species was exotic or invasive or whatever. So it was not working very good. Now, just recently, we thought about getting something out of the box. I asked DALL-E to make something out of the box. So these are the images. So it's inspired by a project which we did with the OCBio team, Open Science for Biodiversity, together with Brussels Environment, where they wanted to use the GBIF backbone in their database. So as a taxonomic reference database. Okay, they did not have all these applications, so that was kind of straight on, but with all our different applications, we needed a simple workflow to cope with the numerous different taxon lists embedded in INBO. It's something very simple. So first we had to do is identify all taxon resources in INBO. INBO is the Research Institute, just to make this clear. We did an ETL, extract, transfer, loader to a new central repository, tried to list, to match all these things with the GBIF backbone, create a feedback loop to construct unified lists, repeat, that's why it's called a washing machine, and we would use the output for analysis and also to try to motivate the scientists responsible for the applications to update or improve their own taxon lists. So we identified 29 lists, 10 animals, 13 plants, 3 fungi, 2 chromista, and 1 bacteria. And we have 15 relational databases running separately, running in the institute. And then, of course, there's a lot of scientists having their own database, but we do not touch that. That's a little bit too far from the centralized system. So the ETL, extract, transfer, load to a new central repository, to get all the taxon lists in one data repository, to match it against the GBIF backbone, find synonyms and information from other checklists. What we did is first a request with the name, preferably the kingdom. We made it the verbose true to get extra info on the match, and so we could use the could find back the species key or the NUP key, and we would only keep that matching information. The second step, so you see the database there, or the data model there. The second step is to, based on this, this key, to get all the information available from the GBIF taxonomic backbone. So that is the response, what you see here. We also would database this. Also, some extra information we could use is getting back the information on the vernacular names. We're particularly interested in English, the Dutch, the French, and the German names in our list. And then also we could match this again with some taxonomic resources on GBIF, some in particular dataset from Waarnemingen. It's an NGO serving a lot of citizen science data with their own checklist, and also the NBN list. We also checked it because we are still using this in our central repository. So get information from other checklists. So in the end, we have this whole model, taxon source, taxon GBIF match, the GBIF backbone taxon, the checklist information, the vernacular name information, and the GBIF checklist taxon. So we tried to roll this, and we had some matches which were bad or fuzzy. We could contact the scientific application manager, and this thing is not automated for the moment, but try to make these messages automatic. So asking to correct the thing in the source application. So they get an email, say, oh, that name is maybe not correct of your double L or what, can you please update your list? Sometimes we do not want to update because a lot of our scientists, for example, they use Anas unox. If you know unox, it's a kind of soup, yeah? So soup in a can. So that's just duck, something like duck-like, and they all use Anas unox, which is of course not a scientific name, but our taxon lists are full of Anas unox, and they do not want to change this. And of course, we need some further development. Also, in the configuration, if they do not want to map or adjust their taxon list, we can do by a little config file that the output would give all the same name. So we had 59,000 entries, and about 55,000 would make a match with GBIF. Only 371 fuzzy match, the rest was an exact match, and that, when it becomes interesting, we had 3,690 about with no match. And then we have a look, we could see that some of these no matches are actually still matchable. So this is what we get from that. The example is Luzula multiflora, subspecies multiflora, and then we can see that this was accepted in Sidonia as in a database. I think that's for that. The 370 fuzzy matches that's quite interesting because that's mostly misspelling, mostly double L, us or R, and that's easy to update. And 575 were higher rank. Only the genus was given higher rank. Sometimes we had more alternatives on species level, so GBIF could not choose which one. Even if you would provide animal or plant, it's still not possible to make the distinction for the API to give back that information. So also a name what we have with the slash, people don't really know what it was, Polygonum minus of might. So it matched with one. Also sometimes the same name for a similar species or heterotypic synonyms. Or no matches, and we tried to see if we could still match these things. If in the taxon list is unknown deciduous tree, well, that's not a scientific name, so there is no match, definitely no match. Sometimes it could be fuzzy, so a match would be possible. Anas unux is soup eend. That's for the people who understand Dutch, but it means soup duck. Higher rank match is possible because we know it's a duck. Sometimes in the list they use the Dutch name, so maybe there is a way to find matches there. Hybrids, that's a little bit difficult, but match would be possible. Informal groups, match would be possible. Every case we have this information, we can have a look at this. It's only 500, no, 3,000, no matches, so 2,000. Still a long list to go through, but I'm sure that we can find some solution for this. This is the winners of the worst taxon list in our institute. Futon taxon is 1,356. No match, that's the dirty laundry. Another one on Sidonia and Florabank. So the conclusions here that we have a working prototype, but we need some work for that feedback loop. So get the scientists in this loop so they can update their checklists or easy update their checklist. And it should improve the reporting because we are a policy institute. We need to always report to the administration using the same lists. And this is also a very interesting way of using always the same name in your reports because these people need to try to understand this thing too. I want to thank the IMBO team, the data management, also OCBio, the Belgian Biodiversity Platform, and Copilot and ChatGPT for the image. And I made a song of this, and I will try to can we have internet? So instead of questions, I would like to show you the song.
No phonogram, do it live.
I don't know what I have to do. I don't know if I still have 16 seconds. No, it's counting up now.
Make sure it is appropriate.
It was asked to make sure that this, If we have time, I'll play the song. If there are any questions in the meantime, maybe we can already try to help you there.
If there are any questions in the meantime.
We just want the song, okay? Do you have it on the phone, maybe?
I have it on the phone. Can I try to have it on the phone?
And you can just hold it on the
It's almost a hit.
Is it on Spotify?
Not yet. I'm gonna not lie to you. I used artificial intelligence to make the song. And I got a version also naming all the databases in our institute. But that's not the one I'm going to play.
Yeah. There is a question for you.
Okay, yeah.
Oh, no, it's no question. It's just... Yeah, so Dimitri, another Dimitri says, very interesting. You might be interested in their session Sim 18 talk also about the taxon laundry machine.
I was also thinking, oh, maybe I'm not in the right session, but I... Oh, I need some sound also here. You need to listen to the text. So I'll share it later.
Send us the symposium chat, yeah.
Okay. Thank you.
Thanks, Dimitri, for that song and presentation. So moving on, I think we're back on track. May I ask now Alice Ainsat to come to the stage for her presentation? Thanks, Alice.
I just click to change the... Yes. Okay. Okay. So, hello everyone. So I'm Alice Ainsa. I am an IT engineer at the National Museum of Natural History in Paris, and I work for the GB France. And today I will present the new features that will be available in OpenOps. So OpenOps is the French national portal for species observation data in France. And OpenOps allows users to visualize, query, and download biodiversity data available in the INPN, the National Inventory of Natural Heritage, which is part of the SINP, the Information System for the Natural Heritage Inventory. The INPN centralizes biodiversity information in France, and OpenOps enables users to visualize these occurrences data. This application is based on the Atlas of Living Australia modules, customized for the specific needs of users in France. We are currently developing two major new features, so the scientific validation and the access to sensitive data, in order to improve the accuracy of the data. So the first new features concern the scientific validation of observations. So we will implement a module for reporting and scientifically validating observation at both national and regional level. Initially, we will focus only on the national validation, and we will do the regional validation later. So the national validation level includes 5 possible values. Certain, very likely, likely, doubtful, invalid and not feasible. And here you have an example of a detailed page with the various fields present for the national validation, with the validity level, validator name, date, type, protocol, and a comment. So with these new features, any OpenOps user will be able to report the validity level of an occurrence if they found it incorrect. They will be able to propose a new validity level and specify the reason for the change, thanks to a form available there. For example, the reason might be an incorrect date, such as a date in the future, or an issue with the data's location, like a terrestrial animal being recorded in a maritime area, or any other reason. And this request will be recorded and sent to validators who can then approve or reject the change. The second new feature concerns the access to sensitive data, specifically precise geographical information. So user will be able to request access to exact location of sensitive data within a specific geographical and taxonomic scope. As for the validation, this request will be recorded and sent to administrator users who will then approve or reject them. So here you have the different location accuracy levels. So you have a point for non-sensitive data and different level of sensitive data. It can be line, polygon, and department. To enable requests for access to sensitive data or data validation, we also need to implement a connecting mode on the website. So development has begun for this part. We are using the LA-Auth module with the INPN CAS, which was already used by the INPN website. So this integration is essential to ensure that only authorized persons can access to these new features. Now let's see the different types of user and the access features that we'll have. So for non-connected users, as it's currently the case, all basic features will remain available, with the added possibility of reporting an observation to change its validity level. Of course, these users can also create an account and log in, giving them access to additional features. Once they are connected, user will have the ability to make two types of requests. requests for viewing sensitive data, and requests for validation of report and also for viewing sensitive data for the same scope. Each request corresponds to a specific geographical and taxonomic scope, and multiple requests can be made. So you can have a request for birds in Brittany and another one for sheep in the French Alps. Users who got the right to access to sensitive data will be able to view the precise location of the data. And for validation rights, users will have the access to sensitive data, but will also be able to view the report within their validation scope to approve or reject them. And they can also modify directly the validity level of the observation within their validation scope. And finally, we will have administrator users who will manage requests users to view sensitive data and validation via an administration tab. At the observation level, here we are on a detail page of an observation which has a likely automatic validation level. So we will add a button on this page to report the observation, and this button will be accessible to every user, connected or not. And when you click on this button, you will have to fill out this form with the proposed new validation level, a command to explain the reason for this new level, and the identity and the email are optional, so you can choose to remain anonymous. And if you want to receive an email to be informed of the data modification, you just have to ask for it on this form. Once the report is made, the report for this observation is logged for all the users and visible to validators within the validation perimeters. And so we will create a new database to list the different reports. So here we are. User has reported a change in the validity level field, and all the report details, so the ID, fields, and the new values, are recorded in the database reports. So now if the validator rejects this report, the reporter will receive an email if he asks to, and the data remains unchanged and the report becomes available again. If the report is accepted, an email is sent to the reporter if he asks to, and the parameters are changed in our database for the next ingestion, but also in Solr, so that the changes will be visible immediately on OpenOps with the new validity level, validator name, validation date, and all the fields. Here is a diagram to remind the ingestion process on OpenOps. So the data team creates an archive in the Darwin Core format. These archives are then sent to Jenkins for the ingestion process. Jenkins uses the ALA pipeline and Apache Spark to process and ingest data. And finally, the data are indexed in Solr in a new collection that we create before. So initially, we will maintain around 3 data ingestions per year, given that data changes will be immediately visible. However, in the future, we plan to have more regular partial ingestions by only ingesting modified data. So we just ingest the data sets that have been changed, and we keep the same collection, Solr collection, and we just update this collection. So to conclude, the connection has been implemented and the functional specifications are completed. We still need to finalize the technical specification, particularly the database model for recording user reports. And the production deployment of these new features is planned for the first half of 2025. So we are interested in hearing from you if you have some advice, if you have any features on your website. So let me know. Thank you. Do you have any question?
Thank you, Alice. Very interesting. I have a question because you said so the moment you are admitted the role of seeing sensitive data, you can view the data also, or you get the data sent by email, or you can, in the portal, view the high resolution data.
You can see you can see it on the portal.
Okay, that's great. We need to meet very soon.
Okay.
In Paris or so, okay?
Okay.
So what decision criteria do your administrators use to decide whether to give or not give access to people who are requesting sensitive data?
So if people ask to see sensitive data, they with the comment and they explain the reason. I don't know exactly, but for individual users, it's just for 30 days. And for people that I think we have to know the people. We cannot give access to anyone. I don't know exactly, but
yeah, we struggle with that as well, trying to determine like who gets access.
Okay.
You know, it's not just like, do I know this person, or it's
Yes.
like, do they have a .gov email, or yeah. So
okay. Yes, we have to think about that too.
mm-hmm.
So those reports, when you gather, you have the report button, and you can get other information. That's extra data on top of the data that's provided. Is it stored in a separate database?
Yes, it's in the report are in another database. Will be report.
Yeah, and they're kept in there. And the other question is, I may have missed it, but who do you select a bunch of people to be validators? Like, are they experts in a particular field or taxa?
It's I work with Patrinat, and there is an expert of animals and any taxon, and so this expert will give the access. And
Are there a lot of them? Are there tens or hundreds, or
I don't
just
know
a
exactly.
handful?
Maybe Anne-Sophie know.
Yeah,
Come up here.
Yeah, sorry. Yeah, in fact, Patrinat is a department where is 100 person, and it's correlated with a museum in Paris. So there is experts which are dedicated to certain taxon and fields. So there is kind of a list of experts, and it's not only in Patrinat, it's also with all the museum. And so depending on the taxa and geolocalization, they asked. Yeah.
Cool. Thank you.
Thank you.
Thanks, Alice. Now, moving on with our agenda, may I ask Heimo Reiner to come on to stage?
Yeah. Hi, everyone. I'd like to talk a little bit about what we do with data from GWIF in the context of phytosociological methods, so like habitat description and vegetation characterization. And we set up a project called FairyCube. And you see the authors like Susanna Ioni, Katy Schleit, and Stefan Jetschny from NILU here. So the FairyCube project was intended to combine people from various domains who might not know of each other and what the possibilities would be. So for us, it was mainly connecting to Earth observation, satellite data, and then include modern methods of machine learning and others to help us characterizing vegetation types. A central point for the project is a so-called FairyCube hub, which contains a catalog section where you have information about availability of layers. It can be also partially machine actionable. So there's a Stack Fast API and a browser. So you can look online, but you can also query directly. There's two tech stacks by companies. One is on the right-hand side, Rasterman, and the left-hand side, EOX. So inside these tech stacks, we have Jupyter Labs installed to process data in the way you want to do it. We have an object store which hosts the resulting cubes and models used for machine learning. And then there are services and APIs, and everything is more or less documented on GitHub. 5 use cases have been identified, mainly focusing on, in the context of the EU, from the European Union, the new Green Deal action items on different scales, from urban to regional to European, and using different platforms to implement it. Our use case is dealing with what I mentioned already in the beginning, the validation of phytosociological classical methods through occurrence cubes. What we try to do is we try to compare a system that is in place in Europe called European Union Nature Information System with remote sensing data, and then adding occurrences of actual occurrences of species using machine learning. I myself I'm not an AI or machine learning guy, so we have some specialists running on this, and then compare the results that we receive. The UNIS system is a European-wide system for habitat classification. It has been established by a European Topic Center for Biodiversity for the European Environment Agency, and it includes classification system for all European habitats based on environmental characteristics and species composition, but the species composition I will explain later is on a selection of species in a certain area. So there are 2 recent publications. One is done by Milan Kitri, 2020, which is called the UNIS expert system. So experts are doing the releves, or the vegetation plots, and they are also characterizing it and then identifying and assigning, partially manually, characteristic species to the habitats. And a very recent publication by Leblanc, the group of Montpellier University, they were advancing it with using and applying machine learning, and they found out that machine learning is by far better suitable for characterizing these vegetation habitat types. To give you an example, we selected 3 species. 3 groups. One is a subalpine species of rhododendron. What we show here is the distribution along the Alps. What you see is blue dots are GBIF occurrences, and the red colored polygons in there are representing the S22 habitat from the UNIS, which is characterized by this rhododendron species. What we then also see is the same habitat type is also occurring in Scandinavia, but there is no rhododendron ferruginum in. So it's sort of like the identification of this diagnostic species is questionable. What we want to do is implement a system with which you can, on the basis of the species composition, not only of diagnostic species, but on the general species composition, characterize the vegetation. We have 2 threads. One is data from the environment in the data processing pipeline, coming from topographic features, hydrologic features, geological features, and climatic data. Put it in the EOX hub, and then get environmental data sets, produce one part for the occurrence cubes. The second stack is then from the UNIS habitats, we get a species list. We select the species, put it into GBIF. From GBIF, we get the resulting occurrence records with coordinates, and then this also feeds into the occurrence cubes. One aspect, and after having received the occurrence cube, is a validation of the characterization of these occurrence cubes, and the other one is, in a machine learning context, balanced bagging is checked for proof of concept if this gives us good results, and then we get our occurrence cubes, and then we will compare them finally with the UNIS habitat classification. 3 groups that I mentioned earlier already we selected. One is subalpine plants, Rhododendron ferruginum and Thyrsutum. So one occurs on acidic soil, one on basic soil. Salix arenaria and Rosmarinifolia is adaptations to sandy soils and lowland plants, and 5 species of annual plants from urban areas. I will go a little bit into detail of this Rhododendron ferruginum, what we analyzed so far and our results so far received. It's a characteristic species. Somebody of you might have seen already the Alps, and this is the Almrausch. So when you drink too much, you get high. Everybody tends to know it. This is additional species. You see there's 2, 4, 6, 7 additional species. We downloaded the data set for only one at the moment. You have the DOI in there. With this, in the beginning now we selected topographic features from the digital elevation model from Austria, which was easier to process than doing it for whole of Europe. What we are including currently is the aspect index, so the orientation of the hillside or a mountain slope, then slope index, the shade index, and from climatic data, the wetness index. Proof of concept with this balanced bagging machine learning approaches, for training the model, we only use part of the data. And randomly sampled subset of these data. The approach is to reduce the initial data volume. So when we initially thought about rasterizing our vector data, this would mean an explosion of data that needs to be processed. So processing capabilities of the cloud computing infrastructure must be very high. So we did it just the other way around. For a certain point on the ground, so XY coordinates based on the occurrences from GBIF, we selected the information from these additional layers. And then all of this is stored in a Python playbook, which can be accessed online at GitHub for this one species. What we found out currently running this balanced bagging method for machine learning is that most important currently seem to be only latitude and longitude, and the slope aspect needs to be considered as well. This is a prediction map for the species based on the environmental factors that we had so far. This is more or less the same situation is shown in the real distribution of the species. And again, the combination of the distribution pattern derived from the GBIF records and the UNIS habitats. You see only a few outliers where there's no GBIF records. The rest are more or less matching. The next steps will be validation of the data that I mentioned in the data processing pipeline, then extend from Austria to Europe, run several additional models for further features like the elevation, geology, seasonal temperature and precipitation, and land cover, and then having an ensemble model applied. Then we repeat the process not only for rhododendron but also for the other species, derive the habitats on the basis of these species, and compare the results with the UNIS classification. An own issue has been pointed out yesterday also in the initial keynote on AI. So validity of the identification is an issue. We selected in this point occurrences from human observations as well as collections. We will filter a little bit to distinguish between those two qualities. And we also implement a validation of the identification process. This is some references that we used and QR codes for the project, for the knowledge base, and for the GitHub notebook or the playbook. And this is the consortium. Thanks. Is there questions? Yes.
So I've never used the UNIS before. By the way, this is really, really interesting. So I'm excited to look more into the use cases that you have set up here. But with the UNIS, it looks like it's quite high spatial resolution.
Yes.
What are you doing to account for the fact that a lot of especially human occurrence data that are coming into GBIF, in mountainous regions, you're not always getting quite as high spatial resolution. So what are you doing to kind of ameliorate some of the issues that come with the disparaging levels of resolution?
Currently, we did not include the exactness measure for the points provided by GBIF.
Right.
We will see what the environmental factors give us as a result, how far we can go with the resolution. The data that we are using for the environmental resolution is about 100 meters square.
Yeah.
Some of them are available in in the urban areas, they are available for, 2 centimeters or something, or even further down. So our resolution for the GBIF data will never be this.
Absolutely. Yeah, especially if you're looking at slope and aspect and things like that, you're going to have to find a way to at least account for that a little bit, but yeah.
We have a consultant for these machine learning topics, and he said maybe the slope is also not good because people tend to get easy access to the plants as well. No, so if the collection is really appearing where it should be, is also questionable. There are several issues. The main issue I just targeted was the identification.
Yeah, it looks really cool though. Thank you for sharing that.
Thanks.
Thank you. I also enjoyed the talk very much. This is the kind of databasing community, and GIS or the map is often like interpretation picture. If this would be a GIS get-together, then what we do is just records, just input. There is a little bit of perspective thing, and you're connecting these two worlds very nicely. What I was thinking for a long time and discussing in GBIF Secretariat as well, that we are dealing with primary data as point occurrences largely, and interpretations of those. Primary data can be polygons and shapefiles.
Yes.
Like from the country I'm born, Larix sibirica, the large, then the shapefile is probably 8,000 kilometers long, and you don't want point occurrences of every large tree in Siberia. So do you see any kind of future connecting this kind of primary data recorded from remote sensing or similar at the species level, like Ericaceae can be identified to species level, and then like do units to shapefiles combination, not to the GBIF dots? Like in GBIF, we cannot support primary data shapefiles yet, but like, do you see the way ahead?
So I did not go into much detail of it. So the talk is about data cubes. Actually, we are not producing data cubes. We are producing, the machine learning guy tells us, data frames. So it's matrices. If we would use data cubes, and if we would rasterize the GBIF data, then the amount of data that need to be processed are soon jumping up to terabytes, or even higher up. So we reduced it downwards. Once we are clear about this, we need to have a publication on it, because it's worthwhile how we got there to publish, not for you to see and to judge if this or the other way would be serving much better. And also I'm working in the tropics myself. My thing was always that the traditional methods for characterization of vegetation never works in the tropics. The diversity is so high. So this was the second angle that I wanted to have. Okay.
Any other questions?
Thank you.
Thanks again to Heimo for his presentation. So now moving on, the next presenter, my colleague Tania Lady, well, she couldn't make it online. However, she left a presentation for us. So when you're ready, guys, if you can play it. Thank you.
From Atlas of Living Australia. Thank you for joining my talk today. I'm going to be talking to you about user-centred design for maximum impact. Australia has undertaken several user surveys since its inception in 2008. Each of these resulted in a standalone report which was then used to capture feedback and user pain points. Each of the subsequent surveys resulted in improvements to our web presence and functionalities. These improvements were undertaken by external providers who approached design from a purely technical point of view and without following user-centred approach. Once the designs were handed over to ALA, there was no continuing support or knowledge transfer to the ALA. Be including talking about our user surveys and species page review processes, how we developed user artifacts out of those and quick wins we were able to implement, then how we embedded our users' needs into our design process, how we improved our taxonomy, and what the outcomes were for our UX, UI, and how we're going to monitor these going forward. Feedback from several different surveys that were run since ALA's inception in 2008. These range from user needs analyses, functional reviews, user polls, and user satisfaction surveys. We compiled all the results from these and made a number of recommendations for the ALA to improve both its user interface and our user experience. Over the years, many issues have been addressed or partially addressed. However, there's still many outstanding pain points for users which kept recurring in multiple feedback reports. In addition to reviewing previous surveys, we sought insights from peer organisations such as GBIF regarding their recent processes for updating their user interface and undertook a gap analysis of the GBIF hosted portals against our user pain points. Internal review of species pages and their content. This included targeted pop-up user survey for species pages, for which we got around 1,000 respondents. We looked at similar species profile sites across the web for best practice, including iNaturalist museum and herbarium websites, Birds Australia and other conservation agencies' websites. We consolidate all the feedback and recommendations for improvements to the layout and content. We then included those recommendations in part of a broader UX/UI analysis of the ALA's websites and products. The ALA species pages being the most highly visited sites on the ALA with the most in-depth and targeted analysis to date was prioritised as the first body of work to uplift ALA's UX/UI. A number of artefacts were developed as part of these reviews and the species page review as well, including user personas, user pain points and user requirements. This here is an example persona of a collections manager. The personas describe a typical role of a user of the ALA and what they want to use ALA for to help their role, their frustrations and their needs. These help us to target specific needs and workflows and for us to aim to reduce user frustrations. Some of the key pain points which were found during these reviews included that users weren't clear which species records have been obfuscated or what sensitive species they were. They were unclear what the difference between expert distributions and occurrence maps were. They were unable to filter images by date or as authoritative ones. They were unclear how to interpret the various types of information in the pages, and often there was quite ALA-centric or technical terms which weren't explained or clear. They felt the amount of information was either overwhelming or the layout too cluttered. It wasn't aligned well, and it wasn't prioritised, making it hard to find the information they wanted. They felt some of the content was out of date or not authoritative, and they weren't clear which taxa were native or introduced. Much of the information was not Australian-centric, so there was very little information about the species in the Australian context. They found that many taxa had little or no content or photos, and they were unclear as there was duplicate pages for a couple of taxa, so with different numbers of occurrence records. Example of our species pages prior to any updates. You can see that there's lots of blank space, information is not organised well and is cluttered. Some of the identified improvements could be implemented straight away, and these included the ability to select a focus or hero image, removal of out-of-date or irrelevant links in other resources, removal of tabs which weren't showing useful information, and removal of outdated or non-authoritative content. We also were able to link directly to Wikipedia content rather than via a third party, which enabled us to show more content on our pages. The rest required some review, design expertise and user input. From the reviews was to set up a UX/UI practice in the ALA, which was better governed, less reactive and ensured a consistent and intuitive user experience across all of our websites and products. So the ALA enlisted the expertise of a UX/UI design company to collaborate with us to build capability within the ALA and develop a user-centred design practice. They helped us by assisting us to develop and embed UX/UI practices and governance within the ALA. We collaborated on the current state assessment based on all our previous work. They delivered a UI design pattern library, high-level information architecture. They provided feedback on our user journeys and personas. which allowed us to improve those. We collaborated on a set of user test scripts and user testing plans, and they delivered new design templates for the species pages, homepage, and basic search designs. A core element of this work, which was different to how the ALA had previously undertaken user interface design, was to involve users in every step of the process. This will result in a more user-centric web presence and a much more enhanced user experience. We developed and tested user personas and journeys, which helped us to develop a suite of user requirements. We undertook a series of in-depth interviews to test designs, both low and high fidelity, with iterations in between to incorporate user feedback. We also included ALA staff in the design reviews to incorporate their extensive knowledge on our products and systems. One of the key user pain points from feedback was data quality. Although ALA has made continual improvements in this area, there's still much more to do. A key element of data quality feedback was around the ALA's taxonomy. The way the taxonomy is governed currently means that it's very difficult and time-consuming to update with minimal repeatable processes in place and no decision framework as to what gets included or not. A decision framework has been developed, including prioritisation of source taxonomies for inclusion. Under this framework, the ALA uses the Australian National Species List as a base source of its taxonomy and undertakes a series of gap-filling exercises using other sources, for example, other national checklists, global checklists, including Catalogue of Life. Checklist Bank was chosen as the most appropriate tool to share and review the taxonomy, as it makes error checking and editing much more rapid, efficient and transparent. As a result of the latest update to the taxonomy, there's been a major improvement, a significant decrease in the number of taxa and the unranked species in the ALA's taxonomy. While there's still much more to do, when loaded, this represents a major removal of duplication and error fixing in the ALA's taxonomic backbone. This update on user experience included reduced duplication in taxa and duplication of species pages, rationalisation of names, standardisation of a higher taxonomy and even easier navigation of the taxonomic tree, improved data quality, for instance, names supplied in the current data sets are more reliably matched to a single taxon, and taxonomy can be updated more frequently. Threatened and sensitive species can be more reliably included with the source of the name in the ALA taxonomy clearer. This will also greatly improve user experience and a look in the interface itself. Some of the changes we've made to the designs include embedding a hierarchical structure for headings to make it clearer to users what content is showing and its relationships, including only a brief description on the overview page, replacing technical terms with more plain text, including flags for sensitive and biosecurity species, including explanatory text where it was indicated there wasn't clarity around what information is being shown, and also combining the species distribution maps and the occurrence maps, so it's more clarity about where these come from and why they differ. We've also ensured that accessibility was front and centre, including colours, spacing, links, text delineation, use of plain language and inclusion of explanatory text. We will continue to monitor and capture user feedback regarding the species pages via our help desk tickets. We'll also baseline metrics such as bounce rate, search engine ranking, click-through rate, page views, and interactions with the various components of the species pages such as the tabs, maps, images and navigation to other pages on the ALA. We'll monitor and report on these at 3 and 6 months post-implementation to gauge if they have improved user interactions. Thank you for listening and thank you for joining me today. I'd also like to thank our UX UI project team and other members of the ALA and the Taxonomic Working Group who have contributed to this project. Thank you.
Well, thanks again for that recording from Tanya. I should have mentioned at the beginning of this session or that presentation that indeed I am here available to cover any questions, but if there is something more technical about taxonomy, we have also our colleague Simon sharing online, and I'm pretty sure also Peggy here can cover those. So, any questions for us?
So what like precipitated this movement into looking into UI UX? Like, did you have an additional grant, or was it like part of whatever funding structure you have coming in, or like was it a special project where you're like, we're going to increase our usability, or was it just part of your standard operations?
Yeah, well, I think that there is the long story is that indeed we have a 5-year strategy plan that, among other things, wanted to address all the user pain points. We wanted to make information access more smooth, and that's why we started to address that. And hence, we went back to the basic and seeing, well, revisiting all the previous surveys or analyses that we had. We validated with new surveys. We also use reports and so on to say, well, to validate, yes, I think this is still a problem for us. It is time to start addressing it. And also from experience, we had probably the job that we did every few years was to refresh only our main website, but we didn't pay that much attention to our core systems because obviously there were also competing priorities. But this time, precisely, we decided to highlight and emphasize just that we needed to start improving, and rather than going back and updating our main website, we say, let's go to our core systems.
Great, thank you so much.
Thank you. In JB France, we are currently reorganize our website for the JB France, hosted on the hosted portal for JB. But we still have open offices in Living Atlases, and this is going to stay like this. But it's just, we are going to organize a kind of JB France Day in the beginning of 2025, and it's something we would like to work on about the users, better know what happens and what even. And would it be possible to have a look at your surveys and reports? To give an example, then
absolutely, yes. Okay. I see no reason why that shouldn't be possible. Mm-hmm. Yes, and in general, just as you know, supporting basically an open source access precisely to all these applications, the new developments for these species pages, we are planning to do exactly the same, but just make it available to everyone.
And Eddie is here and is the one who will work with us on this user thing. So. Okay.
Thank you.
Hi, I'm Jerome from Taiwan, and I understand that AOL is like a very large infrastructure, and so it's going to provide service for a large diversity of users. And my question is, when you are focusing on a UX UI centered like a user design survey, how do you prioritize the such diverse needs of different users? So that's a question. Thank you.
That's an excellent question, and thanks for bringing that. I think part of the approach that we did, as is probably you saw in one of the slides, we were targeting user personas. So rather than trying to target the specific user per se, we took all the commonalities, basically, because from the different user personas, we identify what are the common needs that they need, what is the functionality or workflows. So essentially, we pay attention on those ones. And again, this is still very specific to species pages and search. So we work on those, and that will cover basically a lot of our type of users.
Thanks. UI UX discussion here reveals one particular aspect of TADWIG and people connected to TADWIG. I think we're basically biologists who taught ourselves how to database, and computer scientists who like biodiversity. And the UI UX people whom I met, for instance, in meteorology environment, this is a particular, not subspecies, but particular category of people often with humanities background who know how to listen, how to collect marketing signals and turn them into technical tasks for developing team. I find what you do at ALA is very advanced and rare in our community, because often like UI UX decisions are made either by the management or by developer teams, the front-end people, which is fine, but then it's kind of, it's ignoring the signal from the user. And in the meteorology app, windy app, the blue and the red, doesn't matter, they have paid aspect. When there is money, then there is marketing. We deal with open data, which is kind of detached from the money, which I love, But when it comes to UI UX, there is no kind of incentive to make it nice and usable because it's free. Therefore, it can be whatever. I'm exaggerating on purpose, but is how like it's sort of Katie's question. What makes it kind of real and important for the ALA to listen to the users? Are they angry? Do you kind of count like, or you measure their happiness level and therefore, and you want like a KPI to go up? What is the instrument?
Yes, thanks, Dimitri, for that question. Indeed, it is interesting how we prioritize, essentially, as you mentioned, improving a user interface among other priorities. I think here, one of the aspects, I'm sorry, I am losing my train of thought. I'm sorry, can you rephrase the
Yes, I basically want to know more about like what makes ALA pay attention to UI UX and do this kind of deep thing.
Sorry, got
Basically repeating Katie's question. I want to know more about
Yes, that is all driven by our strategy, where essentially we were prioritizing just making it easier to access our information. And we are highlighting here, again, species pages, and that is one aspect. Just to give you another example is Maps tool. While you mentioned, while we have a good capacity and different applications, we also have a lot of duplication with different mapping tools. We have Spatial Portal, we have maps on the species pages, we have maps on the BioCase, we have Explore Your Area. And again, we need to do a better job just consolidating that. And precisely around that, our KPIs are to basically that we are addressing what has to do with the actual user feedback on our support queue, but also we are monitoring analytics basically on our usage of our web applications. So that is how we are doing that, and hence we started with a baseline when we started this work. Once we release it, again, we are going to set the baseline on how we were and how we are tracking, because there is always a risk that indeed we have to tweak part of what we are doing. Yes. And Peggy, you wanted to further elaborate?
Yeah, I guess I'd just like to add to that the ALA, the strategy is based on a national consultation that we did where we spoke to a few hundred users, stakeholders, a couple of years ago. That came out in that SWOT analysis as really important. Our system's quite old as well, like some of the UI facing systems, and we've got to get to it at some time. And that is, and I just also want to mention that data quality it has a huge focus for us. And sometimes I think that UI UX is a really important contributor to data quality, helping people understand what is actually in, what the data actually is, and using UI UX cues to help them, because some people will look at a dot on a map and go, that's just wrong, and you've got to deal with. I think you can making things clearer for the users. It improves the perception of data quality.
Yes, I want to double check whether there is any question online. All right, there is nothing there. I think we are going to wrap up the questions precisely for this session, but we have a few more minutes to spare, so I wanted us to start a conversation whether you saw a series of presentations, most of them based basically on the Living Atlases platform, but I think the commonality I see here is also we are tackling the same problems, and it looks like probably we saw the example between presentations of Alice and then Dimitri. Well, I think I want what you are doing, but probably my questions here is how we make it more visible, what everybody else is doing, and so we can just improve that collaboration. So I don't know if anyone here from our organizers or the presenters want to give it a go? Or... Yes, please. Yes. Yeah. Just come, Dimitri. Yes. Let's make it more inclusive. Yeah.
Okay. I think I'm really in favor of having a more organized collaboration. I was already thinking we have a very global initiative with people from all over the world, so it's not always easy to get everybody together. What I was having in mind is to make a hackathon or something for developers. These are, I think, in my case, my colleague who is doing all the magic is not here, or maybe next year. But it would be very nice to put the people who are actually in the code and looking into code and changing all the stuff, to put those people together and try to find some solutions ourselves. Because also for the accessibility for sensitive species, there are several solutions developed. It would be nice that we could maybe have more as a community about how to do this, and maybe more solutions should be developed, but at least that we know about this. So bringing people together, first thing I would like to do is bringing the F3 for everybody, will be in Europe, bringing people together, the developers, log them in a room. We have all the questions, and after 2 days we open the room, and they will find some solutions. I have the impression also that my colleague who's doing this is very enthusiastic. It's challenging. It's and I think everybody will agree, finding those solutions. And we see that many questions come over and over again, and the same questions and the same solutions. So that's more, the Living Atlas community. Also, I started this job and I told my bosses, I want to do this in the Living Atlas community. So not only on the island of Flanders, which is an island we know, we're not even a Belgian Living Atlas, but to do it in cooperation and bring people together.
Thanks. Now, and continue with that. Indeed, precisely what you mentioned, Dimitri, brings me back to what used to be the Living Atlases community in the past, and that is before COVID, where I think there were annual workshops. I think they were paired precisely with these conferences. I could be wrong. I was still not around precisely on the actual ecosystem. But I think I completely agree with you. I think it is something that we should seek to reinstate in some form.
I'm available for helping.
Thank you. All right.
That's why we all come here.
And Sophie, Paco, or Peggy, do you have any other topic for discussion? Yes.
Yeah, to follow with what Dimi says, which I totally agree with him. And like you said, it's what we did before COVID. It would be really cool to go back to this, because we organized workshops for ITs, and it was really, everybody was happy with this, and it was working really well. And I think that already the webinars you put in place since the last month, it's already a good beginning, revival of the discussions. And I think we should also continue on these webinars. But like Dimi said, maybe it's not enough. But I think the last webinar, I'm sorry I wasn't able to be there, but my team was there. And it looks like they were really happy with the discussion, thinking that it was really useful. And there was clearly motivation to continue with this, so this also can be nice. Mm-hmm. And I also, France is okay to help organize workshops like we did before.
Yeah, thanks for that. And Sophie, and just to give more background to what Anne-Sophie was mentioning in that webinar, we are trying to reinstate a community of practice within the Living Atlases, precisely to have those regular conversations. So, I think we don't mind precisely just to bring more people on board, because we have Vicente Ruiz precisely as our Living Atlases coordinator, but there is so much that he can do, and he mostly works precisely on the technical space. But having more people precisely helping to organize those events, and I think doing it more regularly, I think it would help precisely to give that momentum. So indeed, if anyone is willing to give it a go precisely and to continue organizing these events more often, feel free to reach out to any of us, Paco, Peggy, and Sophie, or myself. So that we can give you some guidance, basically, on how to get started. Peggy.
So that session was really great. That last one we had about it was in particular about data mobilisation and how each node or Living Atlas organises their data loads, because some of us are using IPTs, some of us are using different technologies, different schedulers, or languages and everything, and going through that was really useful. But I think some of the other reasons why people might use, a country might opt to use it, Living Atlas, I think maybe for 3 different reasons. And I'd like to know whether anyone thinks there might be another reason. There's basically the management of sensitive data and sensitive data handling. There's regionalised spatial data integration. There's regionalised taxonomy as opposed to catalogue of life, right? I think are probably the most common reasons I've perhaps come across, and just the governance factor. So an institution or a organisation may want full control over their IT system. And I'm just wondering if I think that those things form good, those first three things at least form good topic areas for the community of practice, for sensitive data in particular. I think twice we've heard issues today about sensitive data management. How do you organise access? How do you manage that? Because we're finding certainly with threatened species management and landholder privacy, that those sorts of issues are quite big. Biosecurity in particular, as we bring on more and more biosecurity data. So my question is whether there are other topic areas that you see as worth collaborating over, or just even discussing in these communities of practice. Any other suggestions? Nope. That's it. Would anyone like to add anything else?
Sorry, I may be not up to date of what everyone's doing, but I'm curious about how is it going on the integration or visualization of long-term monitoring data? Like most of the things I saw on AOA or most of the platforms, and I'm not aware of a platform or much discussion on long-term monitoring data, and especially the visualization, or how will we show it after we integrate different sources of monitoring data? That's a thing I would like to know. Thank you.
Yeah, that's a really good question. We'll give you a call.
We'd like to know.
Any ideas? We're building, the ALA has a pilot event system that Brazil was having a look at earlier in their talk. I think that's pointing to that kind of capability of reflecting long-term monitoring data, but it's a pilot. It needs work, but I think that's a strong call from ecologists. Please.
You captured, Peggy, a very important difference here. Long-term monitoring data will be coming from two main rivers. That's my forecast. One is indeed fundamental ecology, all the plots, transects, permanent and not so permanent. The other, and then there'll be policy, science policy related monitoring, which is triggered by land management, municipalities and prefectures and things like that. The data structure is exactly the same. The language around it and the skill levels will be very different. So I tried a survey like this, my small marketing attempt in the British Ecological Society, asking like, how do you want your meatballs served, basically? How do you want this event data visualized at the GV portal? And the result is, confirmed by NEON, EDI and other communities there, is that ecologists are very data skilled people. They can transpose, they can play with the data. They might not even need deep indexing. They can use EDI data catalog when only metadata is standardized, and everybody is apparently happy. But Kate just went to American Ecological Society meeting. Maybe the situation is different there. When it comes to science policy, it's not like that. there'll be like very busy administrators and managers who wants like a pretty map here and now, no data transposing, no data tables. So we actually don't have a uniform audience. So this is back to your UI UX work, which is great, but I think we need to segment it to figure out, are there interfaces in plural? Do you want like a baby light version and the heavy full steam ecology version for exactly same content? I don't have the answer. I just want to add this perspective here. We have two big lines of work.
Two big problems, yeah. Dimitri?
Just a quick reply. I agree with that. So we have what we are trying to do for our hardcore ecologists or people who are aware with R, making R packages, making sure that they can access the data and just do their thing. But for our agency of nature and forest, where we have the people sitting behind the computer, they want something chewed, which is already pre-digested. So they only have to draw a little square on a map and get the report and see if they have the permit, they can deliver the permit or not. So indeed, two different things, and I think we also have to look at these things. And for us, our Living Atlas would be mainly going to policy administration, so people behind a computer needing to do something with the data, and we will try to make it already as most digested as can, building on the raw data which we publish.
Yeah, it's difficult, I think, because if we think conceptually about events, and events are all manner of different things, that really it's up to the scientists to decide whether event A and event B are similar, like enough collecting events to be able to be compared. So there's a lot of, it might be difficult for us we might be limited in terms of what visualizations or offerings we can put on an aggregator. I mean, this has been a real difficult thing for us to work out. What's a nice a visualization that you can apply to all of the event data that we get. And there is on the events pilot, and I can share a screenshot with you, a nice, a nice site like a location time matrix that shows where things. It's really nice, yeah. And when I show ecologists, they get very excited, which is great. But even that is problematic and difficult to summarise across multiple data sets. But thanks, I'm really glad that everyone else finds this hard.
Well, if there is nothing else, I think we all recognize all the commonalities. We have common problems to address, and I think, again, this is the base of conferences like this, that the standards and just coming together to try to address those. When it comes to the implementation, I think we are on a similar boat, so let's keep the conversation going. So, if nothing else, I want to thank all the attendees here face-to-face and online for joining us. And let's wrap up with our, let me say, Nife de Biru, basically Okinawa, for thank you, and see you next time.
それでなんかわちゃわちゃしてます。これめっちゃ巻いたってことめっちゃ巻いた。シンプルでみんなの発表が早い。インターネットがなんていうか、あれは何が起きたんですか？急にネット使いたいって言い出した。そういうことですね。こっちにパソコン持ってくると、ここにパソコン持ってくるからっていうのがあるんですけど、データで来てて、データでもってくると、基本的にネットにはつなげられませんっていうので、あの処理さんに初めてつないでみたけど、ヨノパソコンだったらつながらないんですよ。つながらなかった。そうですね。力入ってるから大丈夫です。